Logicflow is a live visual programming environment based on the principles of data transformation through functional pipes. Let's start the demo by creating a project. Here on the left hand side we can see two operations. One is a trigger operation called main. The trigger operation always has an HTTP request parameter, and the request parameter data is then chained by a couple of operations, and we can even chain it further adding an operation call. Now to check the result of each operation, we can click on the details panel and then click on any entity we want to check the value of. Logicflow provides a statically typed programming language with 15 different data types such as string, tuple, union, error, and a special data type called instance, which helps us to work with opaque objects created by class constructors such as promise, date, etc. Along with the 15 data types, Logicflow has 225 operations that can be chained after their respective data type. Now, let's look into the operation data. Operations are first-class entities in Logicflow, which means that they can be passed as variables. There are two ways to call an operation. The first one is to chain it after its respective data. The second one is to reference them as variables and then chain a call operation. Talking about operation parameters, there are three types of parameters. The first one is normal required parameter, the second one is optional parameter, and the third one is rest parameter. Let's undo this. Rest parameters allow us to add any number of arguments in the operation call. Logicflow also supports recursion. Here in the simple Fibonacci operation, we can see that we have a condition data that checks if number is less than or equal to 1 and returns the number. This is the return symbol. If we remove it, we can see we have an error here, and it says that we have exceeded the maximum recursion depth. Now if we put back the early return, we can see the value is correctly calculated. Logicflow memoizes operation calls, which is why computationally heavy operations like this do not take forever to execute. Now let's check out conditional branching and skipping execution. Here we have a union data, and operations like then else take the boolean data, and based upon that they enable the reachable branch and disable or skip the execution of unreachable branch. If we change the value to string, we can see the skipped branch is changed. Logicflow also supports type narrowing. For example, the union data here is of union type, and in the true branch it is of string type, and in the false branch it is of number type. Let's check out error handling. Logicflow supports error types. When an operation is chained incorrectly, it returns an error, and errors also bubble up through the call stack. Here we can see we have incorrectly chained length after param1, which gives us the error. Similarly here we get incorrect parameter error, and if we change the parameter we still get error because the internal error is bubbled up. Now let's check out JavaScript promise support in Logicflow. Here we have a simple promise with resolve and reject callbacks, and based upon the availability of reject callback, we call the resolve or reject callback. If we focus into the await operation call here, we can see that it returns the get message result. Now if we inverse the logic here by chaining a not operation and focus on await, here we can see we get the length of the resolve argument value. Logicflow also provides some special behavior with certain operations such as fetch operation. Fetch operation caches the result based upon its parameter value. So if you make any other change to the editor, the fetch operation is not called until we change the URL. Now let's see how deployment works in Logicflow. Here in the deployment panel we can see two sections: platforms and environment variables. Environment variables can be used normally as variables, and in the deployed code they will be accessed from the env files. Now let's try deploying this project to Vercel. Here I will add a platform and add the API token and click on deploy. After the project is successfully deployed, the trigger operations are listed as live endpoints, and you can also see the deployment in the respective platform by clicking on the dashboard button. Now, if we go to settings panel, we can see that we have project checkpoints here. Project checkpoints allow user to make changes to the project and safely revert back to a stable version. And below checkpoints, we have a packages section which has a set of npm packages supported by Logicflow. Rech is a data fetching library. Rowguard helps to create row-level security policies for Postgres. Faker is a fake data generation library. Date functions is a date utility library. And ffmpeg is not an npm package but a virtual library supported by Logicflow. We can see some examples here. For ffmpeg, we can chain a set of operations and then at the end get ffmpeg command. Now let's talk about some editor features. The editor supports keyboard navigation. You can navigate to any visible entity via the keyboard. The editor is also mobile friendly. Here we can navigate to different panels and also resize them. It is very easy to work with Logicflow and build programming logic from a mobile phone because all you have to do is add operations via button and then choose options from the drop down. So this was the demonstration for Logicflow. Thank you.